So the structure of this lecture is as follows. I'm going to start with some preliminaries, just a basic introduction to Python. Then I'm going to talk about what is called the scientific Python stack. Okay, so the scientific Python stack is basically a set of Python libraries that is very, very commonly used throughout the scientific community, right? They are so well established that by now they are almost by default installed on most high-performance computing systems because they are just basically used everywhere, right? Then I'm going to talk about some Python libraries for materials analysis. Okay, so this is a somewhat narrower aspect compared to the scientific Python stack. Okay, the scientific Python stack usually deals with very general purpose libraries like defining matrix multiplications and that sort of thing, which applies across a wide range of material science problems, while across a wide range of science problems, right? While the materials analysis libraries is really specific to just materials, okay? All right, so as I mentioned, I'm going to provide a brief overview of the Python programming language. This lecture will actually form the basis of your first lab on materials data wrangling in Python, okay? If you are reading the textbooks, then essentially this set of slides is a very quick overview of chapters 1 to 4 of the Python Data Science Handbook, okay? And then the material science part is, of course, not in the Python Data Science Handbook. Those are specifically written by me, okay? The content in this lecture is targeted at giving a complete beginner to Python and the scientific Python stack at least enough background for you to get started. So for those few of you who have never done Python before, this is actually a very important lecture for you to go through, okay? Now, for those of you who are extremely familiar with Python, I have to apologize beforehand. This lecture is going to be boring for you, okay? So, but we need to put everyone on at least the same, roughly the same level before we can actually move on to other topics, okay? This lecture is going to be extremely heavy on practical demos and examples, okay? And I'm also going to state again that coding is best learned by attempting to solve a practical problem. So I'm a firm believer in that. I don't believe that you should learn coding by just say reading, this is how you assign a variable or this is how you construct a class. Unless you actually try to do it, you will never remember how to do it, okay? So the goal of this lecture is actually not to be comprehensive, but we are going to cover at least the very basics of the libraries. And I'm going to also tell you where to look for more information, okay? And this is something that you are going to have to do throughout this course, okay? Because, like I said, I can't tell you, well, in order to calculate an eigenvalue, you need to do this, use this method, right? What you need to be able to do is that you need to be able to go to the NumPy or SciPy documentation and search how do I calculate the eigenvalue given a matrix, okay? So it is essentially I'm teaching you how to fish rather than fishing for you, okay? So, and that's, I would say, much more important than actually going through the method names and that sort of thing. All right, Python, right? So what is Python? So for those of you who do not know, Python is a general purpose high-level programming language. The design of Python is such a way that it actually emphasizes code readability, right? So the way that Python is designed is such that it actually uses a lot of white space. So very well-written Python code always have a lot of white space indentation to really show you modular blocks of code, and then when you read the code, you can actually immediately tell what the code is doing, okay? So that's always the mark of a good piece of Python code, right? It supports multiple programming paradigms, so if you are like me and someone who likes to do object-oriented programming, you can do that. If you prefer imperative, functional, or procedural programming, you can also do that. Okay, there is no constraints on what kind of paradigm you are using. Okay, Another thing about Python is that it is dynamically typed with automatic memory management and a large standard library. So what these three terms mean is that it is very friendly to a beginner to programming. Okay, dynamically typed means that unlike a programming language like C, where you have to say x is actually an integer, okay, you don't actually need to do that in Python. You just say x equals to 1, and Python automatically assumes that it is an integer. It will infer what type of variable it is without you having to declare what the variable is. Automatic memory management, again, it just means that the Python interpreter itself will take care of assigning memory space for all your variables. You don't have to worry about, well, I need to create a pointer here with this size in order to hold this variable. Okay, that's actually what you need to do in programming languages like C, and that's actually very painful for a beginner to understand and try to do. Okay, the large standard library, it is what the Python community also call batteries included. It means that it has a lot of functionality already built into the default Python installation. Okay, so you don't actually need to, for example, if you need to read strings or pass HTML files, you don't actually need to install an external package to do it. I mean, there are some external packages that will do certain functions better than the Python standard library, but by and large, you can do a lot of stuff without having to rely on external packages. Okay. Now, Python has become so popular that essentially it is also available on all platforms that you can think of. Okay, so regardless of which machine that you're using, whether it's Windows, Linux, or Mac, you should be able to find a Python installation for your system. Okay. Now, just to show you why Python is preferred for a beginner, so I just want to compare. For example, let's say you just want to print out hello world. This is of course one of the most basic things that every beginner to programming languages start with. For Java, you actually need to go write all this a lot of craft. Okay, you need to declare the class hello. You need to declare a main method, and then you need to call system.out.print hello world. Okay, in Python, all you need to type is print hello world, and you're done. Okay, so this basically just shows you essentially that the design of Python is such that with a minimal amount of code, you can actually do a lot of stuff. And it is very obvious to you what the code does, right? You read this, you immediately know what this is meant to do versus something like this, okay? All right. By now, actually, this question is actually a bit moot, but since Python 2 still exists at some corners of the universe, okay? So I do want to state that a number of years ago, since 2008, okay, Python actually transitioned from Python 2 to Python 3, and that was actually a very big transition because Python 3 actually had backwards incompatibility with Python 2. In other words, things that were written in Python 2 does not automatically run on Python 3, okay? So, however, it has been so long that most of the modern libraries have already transitioned to Python 3. So, that's the modern version of Python that we will be using, okay? So, the version of Python that we will use is Python 3.9 plus, which means anything that is 3.9 and later. It can be, right now it's already at 3.12, okay? But I would actually encourage you to use either 3.10 or 3.11. Okay, it really doesn't matter all that much, but we usually do not want to take the absolute bleeding edge of Python, okay? Because sometimes the newer versions, first of all, they have more bugs. Some of the libraries that you may want to use actually has not been tested on those Python versions. Then you may encounter problems, okay? So, either 3.10 or 3.11 is fine, okay? As I mentioned, there are two options for this course. You can install Python on your laptop. It is faster. You do not rely on your internet connection, and you actually can also install the most modern version of Python possible that you want to use. You can also use Google Colab. These are essentially online Python notebooks. Later you will know what they are. There's no installation required at all. but the Python version and installed libraries may be actually older versions. Now, it doesn't matter for this course so much because when I wrote most of the code, I made sure that I'm using most of the common functionality within the libraries. I'm not using like the bleeding edge versions. However, sometimes you yourself may want to use some latest and best functionality. Then you actually you may want a more modern version of Python and the libraries. Okay, the lag is actually quite significant, right? It can be lagging by several years. So for the longest time, Google Colab was running on Python 3.8. Okay, and that was basically just bad. Okay, recently they have upgraded to 3.9. So now, regardless of whether your OS comes with Python, if you intend to actually install Python, I would recommend that you install it using what is called the Anaconda distribution. So this is basically a distribution that is distributed by the anaconda.org organization. Okay, there are two versions of the Anaconda distribution. One is called Miniconda, and one is called Anaconda. Miniconda is basically just a very minimal version. It has the Python interpreter itself, and it also comes with what is called the Conda command line tool. Later I will tell you what it does. It is basically a package manager. So in other words, rather than just using your standard Python installation tools, you can also use Conda to do installation. And very often, especially if your packages are built with C extensions and that sort of thing, using Conda to install them is a lot easier than using pip. Okay, Anaconda is sort of like essentially a replacement for MATLAB. Okay, it is very big. I think it's several gigabytes if I do not remember wrongly. Okay, but it is basically Miniconda, and it throws in all the packages that you will need and a lot of things you don't need. Okay, so it will come with NumPy installed, SciPy installed. There is some version of some scientific package for astronomy and that sort of thing. So you can actually use that as well. Okay. My personal recommendation is to just use Miniconda because, like I said, Anaconda does come with a lot of things that you may not need. Okay. All right. So let me start with a little bit on the basics of Python. Okay. So as I mentioned, Python is dynamically typed. That means that you do not need to declare your variables. If you just want to set x equals to 1, you just type x equals to 1. They automatically assume that x is going to be an integer. If you say y is equals to 2.0, with the decimal point, they automatically infer that this is a floating point decimal. Okay, so of course, conversion between them is quite easy. Python also has a string variable, a list variable, and a dictionary variable. Okay, so these are the 5, I would say. There are a few other fundamental types, but these are the 5 variable types that you need to definitely be aware of. Okay, integer, float, string, list, and dictionary. Okay. Now, basically, a list is just a list of items. It can be a mixed set, so it doesn't have to be all integers. It can be a mix of integers and strings, and mix of, as well as floats. It can also be a list of lists. It can be a nested list as well. Okay. A dictionary essentially is what is called a key value pair. In other words, it maps one variable to another, right? So this basically says I'm going to map A to 1, B to 2, and C to 3. Okay, so this is basically what a dictionary is. Now, other than some basic operation and functions, most of the other functions are in packages and modules, and they must be imported before use. Okay, imported means that you actually need to have this at the top of your program. Say, for example, let's say you want to calculate the sign of some number. That's actually in the math module. Okay, you need to import math, and then once you actually have imported math, you do math.sign. This is of course pi, and you will see that it gives you approximately equals to 0. Okay, And as I mentioned, please go through the official Python tutorial, chapters 1 to 3, and they will actually have examples for all this. Okay. Now, let me go back to the lecture 1 examples. Okay. So now, so this is I've already opened this in Google Colab. I just want to show you how you actually go about using it, right? So here I actually want to introduce you to some Python basic types, okay? So each of this is basically what is called a cell, okay? By default, a cell essentially is an executable set of instructions, okay? So what you do is that you can either click this play button or you can just do Shift Enter. Well, it says that it is not authored by Google, it's authored by me. So if you trust me, you just run it, okay? The reason why they give you that command is because tell you that is because, of course, there's always a chance that you can write some nasty stuff and delete everything, okay? All right, so that basically ran that particular cell. If you want to confirm that all these things are already done, so for example, let's say I want to define z is equals to x times y, x is equals to 1 and y equals to 2, so obviously I know that the value is supposed to be 2. I run this and you see it comes out as 2, okay? Precisely what I would expect it to be, okay? One thing you will notice is that when I type my Python code, now there's always white space in between, right? So you see that after a comma, I always put a space. After a semicolon, I also put a space. Now, obviously the code will run perfectly fine if you omit all those spaces. Well, there are some spaces you can't omit, but those spaces you can omit if you want to omit them. But there is a set of Python conventions, okay? So there is a set of, not unspoken, it actually is spoken rules that a good set of, a good Python programming practice is to have white space in between all those commas and semicolons, right? So this is where I would say that 10% on your programming style comes in, okay? I am going to look for those things because if you don't follow all those conventions, what will happen is that your code will be a mess and it's going to be extremely difficult to read, okay? And when that happens, that's basically bad programming style, right? All right. Just to show you a few other things, okay? So for things like lists, okay, you can, of course, get the items, okay? So let's say I want to get item at index 3 in the list, okay? So my list is 1, 2, 3, and A. Item number 3 is not the number 3. It's actually A, okay? I want you to remember Python uses zero-based indexing, okay? Which means the first item is 0, the second item is 1, third item is 3, third item is 2, and fourth item is 3, okay? So this is something that you need to be very careful about, especially if you are new to programming. A lot of people may just think that L3 means the third item, and then they count 1, 2, 3, and then they think it's actually 3. It's actually not, okay? You can also get the index of an element. Let's say you want to know what the index of the number 2 is basically index 1. And of course, you can also combine lists together just by using the addition operator in this case, okay? So if I add the list with itself, it basically gives me a list that has 1, 2, 3A, 1, 2, 3A, okay? Now, dictionaries, as I mentioned, are essentially key value pairs. What this means is that if I want, so the way that you actually access an item in a dictionary and the way that you access the item in a list is fairly similar. You use these square brackets, okay? In a list, the index must always be an integer, okay? So because a list is basically, a list is essentially a dictionary but with integer-based keys, okay? But for a dictionary, of course, you can just say, I want the value corresponding to C in the dictionary, okay? If we go back to this, we see that C is basically 3, and if we run this, we basically get 3. Okay. All right. So that pretty much shows you some of the very, very basic functionality of Python. Please go through the Python tutorial, especially if you are completely new to Python, and you should also try to go through the flow control as well. Okay. Let me go back to the slides. All right. Now, one of the best practices for you, especially in terms of if you are setting up your own Python environment, if you are using Google Colab, this doesn't apply to you, but if you are setting up your own Python environment, what you should do is to set up isolated environments for Python. Okay, what this means is that you actually have an isolated set of codes that isolated set of virtual environments that each has its specific purpose. Okay, so let's say, well, you have one isolated environment for Nano 181 or 281, and then you can have another isolated environment for maybe your research project that you are doing with your PI. Okay, and the reason why you want to do this is because sometimes there can be conflicts between dependencies, right? So, for example, one of the dependencies that may be used in your research project may be completely incompatible with the package that you are using for Nano 281, and you don't want them to be mixing together, right? So by using virtual environments, you can actually make sure that the two are kept separate and you don't actually mess things up, all right? So with the Conda, mini Conda or Anaconda, you actually get this package manager called Conda, and this actually comes with the ability to create virtual environments, okay? So for example, if you want to create a virtual environment for our course, let's say we call it NANOx81. So you just do conda create -- name NANOx81. This basically tells them that you want to give the virtual environment the name NANOx81. It is a Python environment, and you can specify the Python version. Here I wrote 3.9, but feel free to use 3.10 or 3.11. Okay, and then to activate the virtual environment, you just need to type conda activate NANOx81, right? Now, once you activate the environment, basically anything that you install from that point is installed into that virtual environment, okay? And once you exit from that virtual environment, those packages are no longer available, but they are also not going to pollute other virtual environments that you are working with, okay? Now, let's say at some point you are playing around with your virtual environment and you do something quite silly and you somehow mess up all the dependencies, or the code just basically doesn't work anymore, and you say, oh my god, I need to restart the whole process. You can basically just do conda remove, give it the name, and the parameter all that basically just tells conda to basically delete the entire virtual environment, and then you restart the whole process again, okay? You can also create reproducible environments in a file, okay? So basically, once I have set up my virtual environment properly, I can actually create this YAML file, which allows me to say I'm going to give it to someone else and say, please use this file to create your virtual environment. Then you have exactly the same environment as I do, right? So this guarantees that if I pass you a piece of code to run in this environment, you should be able to reproduce what I have done exactly, okay? So in our case, for this lab, for this course, I have already created this NANOx81 environment file. It is in the GitHub repo, so you can actually access it and create your virtual environment if you intend to install Python on your own machine, okay? Now, as I mentioned, conda is also a package manager. Package manager means that if you want to install additional libraries of Python that gives you functionality that you need, you can use conda to install them. So for instance, conda install NumPy, SciPy, Matplotlib, Seaborn, and Jupyter. Basically, these are all the packages in the scientific Python stack that we will be using throughout this course. There's also some data science tools. Pandas, scikit-learn, and TensorFlow. TensorFlow is optional, so I would say probably you don't want to install TensorFlow. But scikit-learn and Pandas will be using it extensively, okay? The material science library that we will be using is called PyMatGen. This is actually a library that I myself wrote when or rather started when I was still a grad student. Today it's actually used by millions of people worldwide, and we actually have there have been a lot of contributions from other people. So it is no longer a code that is written by me, but rather written by the material science community as a whole. Okay, so this is a library that we will be using in this course for manipulating material science information. Okay, and you will see how to use it as later. Okay. Now, to update a package, you can also use conda. Just type conda update numpy, for example, and it will update the numpy to the latest version available. Okay. All right. I already demonstrated this. Okay, so this is the Google Colab demo. The link is basically colab.research.google.com. You can create a blank notebook, or you can, as I mentioned, you can actually select the notebooks directly. Most of the data science packages that we are using in this course, they are already pre-installed on Google Colab. So you do not need to do any installation at all. Okay. However, there are sometimes you do want to use Google Colab with a package that does not come pre-installed on Google Colab. In that case, you would need to install it. Okay. And one example of such a package is actually PyMatGen. Okay. So Google Colab is meant for general purpose coding. So things like material science library, they generally don't come pre-installed. So to install PyMatGen, what you need to do is to add this particular command in your very first cell, the exclamation mark pip install PyMatGen. Okay, so exclamation mark just tells the notebook that this is a shell command. So in other words, you are going to the shell to run the command called pip install PyMatGen, and that will actually install PyMatGen, and you can then go ahead and use it in your Google Colab platform. Okay. All right. Any questions so far before I move on? Okay. Let's continue. So I'm going to talk about first. I'm going to give you a very brief rundown of what is called a scientific Python package. Okay. The scientific Python packages are basically a set of very commonly used Python packages throughout the scientific community. Okay, so we are going to use most of them, and in fact almost all of them except TensorFlow maybe. And let me first give you a very high level overview of what each of them does. Right. So the first thing you need is basically Jupyter. This is basically a software for interactive computing, right? In fact, when you are running code using Google Colab, that notebook platform that you see, that is basically a Jupyter notebook platform. Okay. So it is essentially sort of like a web-based page for you to write code and run commands and that sort of thing, right? Now, the other package that you will become intimately familiar with is called NumPy. It stands for numerical Python. It is one of the earliest Python package out there. It is the fundamental package for numerical computation. What this means is that as long as you are not simply working with scalars like integers or floats, but you actually want to play around with more complicated stuff such as arrays and matrices and doing matrix decompositions and eigenvalue operations and calculating inverses of matrices and that sort of thing, you would actually need to use numerical Python. Okay. The good thing about numerical Python is, of course, that it is written in C in the backend, so it is actually very, very fast. Okay. So I would say that although you often hear people complain that Python is slow, you will actually find that that statement is not true most of the time. Okay, if you actually do a lot of your operations in NumPy, you will find that they are generally as fast as any C code that you can write. Okay, SciPy is I would say an extension of NumPy in some ways, okay? It basically implements things like numerical routines, such as things for integration and optimization, and this is basically something that will be quite important in this course, okay? Pandas basically defines a package for data structure for you to do data science with. So this is one of the default packages that almost everyone uses when they are doing data science, okay? And again, this is something that you will become very familiar with. Scikit-learn implements all the machine learning models that you will be playing around with. I'm going to talk about it a bit later. TensorFlow is developed by Google. It is basically a library for developing and training ML models. The reason why we are not going to be using TensorFlow in this particular course is that the learning curve for TensorFlow is fairly high. And I don't really want to confuse you by introducing you a second package for implementing ML models. I would rather you learn Scikit-learn and use Scikit-learn to understand the basic principles of all the different ML models. And eventually, if you feel like you want to work with TensorFlow, you can go ahead and learn it yourself. It's not that difficult, okay? And then finally, the other two packages, Matplotlib and Seaborn, those are essentially plotting libraries, okay? So they do nice plots. Seaborn is a bit more user-friendly because it is designed for statistical data visualization, okay? So, and I'm going to talk a little bit about that later, okay? So I'm going to give you a brief background on all these packages. Again, I want to stress that all these packages have an extensive suite of functionality that it is not possible for me to comprehensively cover all of them, right? So what I'm going to focus on is basically modules and methods that pertain to the data science problem that you are solving. And you have to be able to go through the documentation yourself to find the relevant methods when you actually need to, okay? So please do not expect that I'm going to actually just tell you exactly, please use this function to do this, okay? You need to be able to say, well, I need to do this. What is the function? Let me Google for what function am I supposed to call to actually do this, okay? NumPy and SciPy are the backbone for many other packages. So I'm going to talk a little bit about the basics of NumPy arrays and how do you perform a few simple linear algebra operations. But by and large, I would say, surprisingly, you are not actually going to work with NumPy itself or SciPy itself that often. What you will actually be interacting with the most often is actually this package called Scikit-learn, which is where all the different machine learning models are implemented. And you are, on the back end, they do use NumPy and SciPy to do stuff, but you don't actually, you may interact with NumPy only on a very limited basis, okay? All right, let me start with Jupyter Notebooks, okay? So as I mentioned, we are going to be using Jupyter Notebooks for going through demonstration codes. The Jupyter Notebook is basically just an open source web application to create and share documents that contain code, equations, visualizations, narrative text, and so on and so forth. All the lecture examples are given as Jupyter Notebooks. And for your labs, what I'm expecting from you as a submission is your Jupyter Notebook, okay? So you are not going to give me Word documents or PDF files, all right? So you are submitting your actual Jupyter Notebooks in the Canvas system, and we will run through your Jupyter Notebooks to see whether your code actually does what you say it will do, okay? The documentation, I have provided a link, and if you are running a Jupyter within your own machine, the way you start the Jupyter Notebook is just by typing Jupyter Notebook, and what that will do is that it will run the Jupyter Notebook server, and that server will be running at this address, which is http://localhost. Typically, the port will be 8888, okay? That's the default for Jupyter Notebooks, but sometimes it can be something else. Just read the terminal output, and you should know what address you need to go to, okay? So let me go through a few things that you need to be aware of. Okay, so to run a code in the cell, you just do shift return. Okay, and there are also helpful things to do that comes with Jupyter Notebooks, like tab completion. There are also magic functions. Okay, I'm going to go through this in a short while via an actual demo. So the main ones that you need to know are question mark, exclamation mark, and percentage. Okay, I would say basically the most important is the question mark. Okay, you can also write text and narrative. So it doesn't mean that everything you type in the Jupyter Notebook has to be code. It can be, you can actually write text and narrative as well. You can just set the cell to what is called markdown mode, and you can type text using markdown. All right. You can also make plots, okay, and the plots will actually appear directly in the notebook itself. And the reason why Jupyter Notebooks are such a powerful tool is really it's very useful for quick code prototyping and data analysis, right? So sometimes I just need to figure out how to do something. I will type it in the Jupyter Notebook, and I can change the code as I go along and then rerun that cell and figure out what is happening. Okay, so let me now do a very quick demo. So this is basically the Jupyter Notebook, right? So I can insert a code. Let me insert a code cell. Okay, so let's say instead of wanting to write code, I actually want to say something, right? Let's say I want to say this is the demo for Nano 281. So I can actually instead of doing this, I can do a text cell. Okay, so right, so I can insert either a code cell or just a text cell. A text cell just means that it is somewhere for you to type text. If you are familiar with the markdown syntax, you can even do something like using markdown language, like see, and you can create a header and type the text. Okay. Now, as I mentioned, Jupyter Notebooks come with some magic functions. The most important one is the question mark. Okay. Now, what does the question mark do? Question mark is actually a very quick way for you to get help. Okay. Let's say I'm going to do a sign of a number, right? Let me import the math package first. Okay. And I want to use the sign function that is with so first of all, one thing you can do in Jupyter Notebooks is also tab completion. Let's say maybe there's a method name that's especially long and you don't actually remember what it is. Sometimes you just type part of it and you type tab, and then it will just complete it itself. Okay. So for example, if you just type sign, you can see it actually comes out. Okay. So this is sign. Okay. So this tells you this is the name of the function. Now, what if let's say you do not know what you should be using with the sign function? How do you know whether am I supposed to give the input in degrees or radians? Right? So without reading the documentation, you do not know, right? And of course, you can go to Google and type, well, please give me the documentation for math.sign, okay? But in Jupyter, an easier way is to just give it a question mark, right? A question mark basically just say, show me the documentation for this method, right? So once I type this, you see it basically tells the help immediately pops up. The signature means basically how do you use the method. You basically say math.sign of x, okay? And the docstring basically tells you what the method does. It returns the sign of x, and the x is measured in radians, okay? So now you know that I'm supposed to give x in radians, right? So and method pi just means pi, okay? So now I use it, and you see that this is the answer for the sign of pi, right? And well, it's not exactly 0 because there's some floating point representation issues, but 10 to the power minus 16 is effectively 0, okay? Okay, so remember this question mark thing, okay? So question mark is especially important when you are working with a lot of libraries that you're not familiar with. You do not want to go to the actual web documentation to try to search for what it is. Usually just by typing question mark, you can immediately get a very good sense of what it is supposed to do, okay? And and that speeds up your use quite easily, okay? So NumPy is basically a fundamental package that implements the array and matrix objects, okay? So in other words, whenever you start doing anything that requires not just scalars, but having to do with arrays of numbers or matrices of numbers, you will almost certainly be using NumPy, okay? So this is a fundamental package nowadays. In essence, almost all scientific code would depend on NumPy, okay? The underlying implementation is actually in C, in the C programming language, and hence the operations themselves are extremely efficient, okay? So despite what you may have heard from other people about Python being slow or inefficient, if you actually do a lot of work in NumPy, the code can be basically as fast as a C program, okay? The operations are vectorized, so if you actually say, for example, multiply two arrays of numbers together, it's much better for you to use the underlying NumPy functionality, which is a lot faster than, say, you writing a for loop to actually go through the numbers and multiplying them separately, okay? Since there are two objects, one of the main questions for any newcomer is always, should I use array or should I use matrix, okay? I would say the same thing as what NumPy would tell you, basically that ignore the matrix object, okay? There's almost under no circumstance that you actually will want to work with the matrix object. So just use the array object, okay? If you use the array object, there are some things that you need to remember, okay? So first of all operations such as addition, subtraction, multiplication, and division, when you apply them on NumPy arrays, they are element-wise, okay? I'm going to demonstrate what that means later, okay? What this simply means is that they are multiplication of two NumPy arrays is not like a vector multiplication or dot product, which actually would be a sum of the multiplication of the two arrays, okay? So for matrix multiplications, what you actually need to do are basically what you need to do is basically to use special NumPy functions. So there is actually a specific function called a NumPy dot, which is what you actually use to perform a dot product in NumPy, okay? Since we are already using Python 3.7 and above, another way to do this is using the special operator, which is the @ symbol, okay? For those of you who are familiar with MATLAB, which I think a lot of you are, especially if you just did Nano 15, I think, it also helps to read the NumPy for MATLAB for MATLAB users doc, okay? So let me click it so that we can go there and see what it is about. So there is this very useful document that NumPy themselves have prepared for MATLAB users, and they will tell you about what are some of the key differences between NumPy and MATLAB. They are actually very, very similar, right? So, but in MATLAB, the basic type, even for scalars, is a multi-dimensional array, and in NumPy, it is always a multi-dimensional array, okay? one thing that you definitely need to remember is that in MATLAB, when you index numbers, index a list, it is one base indexing, right? So the first element is 1, while in NumPy and basically all of Python, they use we use 0 base indexing, which means the first element is actually 0. Okay. Other than that, the rest of it I will leave it to you to read yourself. But what is the most useful is basically this part where they essentially show you what are the equivalencies between a MATLAB function and a NumPy function, right? So for example, this is how you write a comment in MATLAB, which is a percentage. In NumPy, you use a hashtag, okay? This shows you how do you write for loops and how do you perform an AND. Things like, let me go to something slightly more important. So let's say if you are interested in getting a transpose, so a transpose in NumPy, so wait, where's the transpose? Yep. So a transpose in MATLAB, you basically use the single quotation mark, but in NumPy you actually have to do a.transpose or a.t, and basically this shows you essentially some of the common functions that you would do in MATLAB as well as NumPy, and what are the syntax differences between the two. Okay, so if you are not that familiar with NumPy but you are very familiar with MATLAB, definitely this would be a very useful thing for you to just get a quick read, and when you are actually working on your labs or exercises, you can refer to this if necessary. Okay. All right. I'm going to show you some NumPy examples. Okay, so these are the code that we are going to go through. First of all, to construct an array, typically when you import NumPy, people usually want to give it a short name so that you don't keep having to type NumPy. So the general convention is to import NumPy as NP, okay? And once you have imported NumPy, to create an array, what you would do is that you say x is equals to np.array, you give it an array of numbers. This basically creates a 3x3 matrix essentially. It is a multi-dimensional array. It's a 2-dimensional array, okay? So basically a list of numbers, right? And here we create y, which basically is just a 1-dimensional vector, okay? So just 3 numbers in one row. And again, you still use np.array, okay? And to show you that the multiplication is not behaving the way that you would think a matrix multiplication would behave, let's say you take x multiplied by itself, you basically get this output, right? Now, this is obviously not the matrix multiplication of this matrix, right? This is actually basically just each of the elements multiplied by itself, right? So 1 times 1, 2 times 2, 3 times 3, 4 times 4, 7 times 7, 6 times 6, okay? So this just shows you that if you just use the star operator of Python, what you are getting is a element-wise multiplication and not a matrix multiplication. Now, if you want to do a matrix multiplication, what you do is that you use the NumPy function called dot, all right? So basically np.dot, these two matrices, and this is the output, which is basically your matrix multiplication, okay? Now, let me go to the Jupyter notebook so that we can actually show some examples. So this is our lecture 1 examples. So let me first import NumPy, okay? So I created exactly the same, let me zoom in a little bit. I created basically the same matrices. So the x is basically a matrix, 3x3 matrix, and y is basically my vector. And This just shows you that if you run it, this just prints out the matrix and the vector itself. And I want to show you that essentially all operations are element-wise, right? So if you do x plus x, it's just the sum of the matrix of the elements of each of the matrix. If you do x times x, it's basically the product of each of the elements of the matrix. And if you do y times y, it is also the product of each element of the matrix. Okay, so they are not the dot product. Now, if you want to do the dot product, you actually use the numpy dot dot function. Okay, and this basically gives you the dot product. And if you want to do a matrix dot product with a vector, you still use the np dot dot function. Okay, so this is basically you take the x matrix, multiply dot product with the y vector, and this basically gives you the output that you see here. Okay. Now you can also use the add operator. So if you look at here, I'm using the new Python operator, which is available from Python 3.7 onwards. This add operator also does a dot product. Okay, so or matrix product, right? And here I show you, you basically get the same answer as you would get if you use np dot dot. Okay. Now, NumPy also has standard linear algebra functions. So, for example, let's say you want the inverse of a matrix. So, in the linear algebra package, you can under the NumPy package, you basically have NumPy dot linear algebra dot inverse of x. This gives you basically the matrix inverse of x. Okay, and this is the answer that you get here. All right. And you can also get things like eigenvectors and eigenvalues. So for example, inside the linear algebra package, there is this function called EIG that basically stands for eigenvalue. And if you run this on our X matrix, basically you see that you get two arrays. One is just an array of numbers. The second one is basically a matrix. Okay, the array of numbers are essentially your three eigenvalues. Okay. And the matrix itself is basically your three eigenvectors, right? Okay, so this EIG basically gives you your eigenvectors, right? Now, again, I just want to stress this again, that if you are not sure about what the function of a method is, the question mark is always a very useful function to use. Okay, so if I put question mark, you see that it calls out this help, which tells you that this computes the eigenvalues and write eigenvectors of a square array. And what are the parameters that you have to give it? So you need to give it A, and A is a m by m array. Okay, and what it returns first of all W, which is the eigenvalues, and it also gives you the eigenvectors. Okay, so if I go over here and scroll down, so it uses W and V. V is basically the normalized eigenvectors of the matrix. Okay. Now, in some instances, for example, if your matrix itself is singular, what is going to happen is that you sometimes will encounter an error, like NumPy will throw you an error called linear algebra error that basically tells you that your matrix, they cannot actually find a matrix eigenvalue. Okay. All right. Okay, with that, that's for NumPy. All right. Now, the next package we are going to look at is called SciPy. SciPy basically implements numerical routines for things like numerical integration, interpolation, optimization. It also implements some linear algebra routines, which are essentially overlapping with NumPy a little bit. And it also has functions for statistics, right? And this is actually somewhat useful, especially when you are working with data science, right? SciPy has its own linear algebra package, which is called scipy.linalg, okay, linear algebra. It is essentially a superset of the NumPy linear algebra routine. package. And the good thing about the SciPy version of the linear algebra routines is that it is always compiled with the LAPACK, which is basically a very efficient implementation of your linear algebra algorithms. So whenever possible, especially if you have both NumPy and SciPy installed, it is actually better to use the SciPy linear algebra package. Okay. SciPy is also a dependency for most of the other packages that we are using. Okay. So just to show you some of the functions that we might be using. So for example, SciPy has this package called stats. This basically implements a lot of statistical functions and distributions, right? So for instance, if you want to get a Gaussian distribution, you do stats.norm, which stands for normal, the normal distribution. 0, 1 means that I want the normal distribution with a mean of 0 and a standard deviation of 1. And then you can calculate things like what's the cumulative distribution function of the normal distribution up to 1.96, value of 1.96, and this gives me 0.975, which is basically the 95th percentile cutoff. Okay. SciPy also has a lot of physical constants already implemented in it, right? So, for instance, let's say you are interested in the value of the electron charge, right? So the constants package in SciPy, you can basically just constants.e, this is basically the value of the electron charge, okay? And this physical constants are all updated from the NIST website, so they are basically the latest values according to physics, okay? So when you are doing your labs, you may be doing some unit conversions. There is absolutely no reason why you need to go to, say, Google and try to type what's the electron charge number and then copy that weird float value and put it into your code, okay? All these things are already available in scipy.constants, okay? Now, let me show you the documentation, okay? This is the documentation of SciPy itself. You generally, when you import from SciPy, what you would do is that you would import the package itself, and then you do the package.curvefit or package.variable name to get the basically the functions that you need. Okay, so this documentation is actually very, very useful. So I want to show you scipy.constants. This basically shows you all the constants that are defined within the SciPy package. So things like pi, of course, the golden ratio, c, basically the speed of light, the Planck constant h bar, the electron charge, of course, E. Okay, they also have a name called elementary charge. That's the same thing. Okay, the gas constant, Avogadro's number, so on and so forth. Okay, so practically any physical constant that you potentially will be using within this course, the likelihood is more likely than not that they are already here. Okay, so things like the Boltzmann constant, for sure you'll be using it. Okay, so remember this package. All right. All right. Let me go to the examples. I also want to show you that that a lot of times, whenever you are writing a code, it's very useful to rely on the underlying NumPy or SciPy functions, so that you can actually exploit the fact that it is written in C and the functions are very well optimized and vectorized, and they are a lot faster. Okay, so what I'm doing here is that I'm creating basically an array of 10,000 random numbers. Okay, it doesn't matter what the numbers is. Okay, so you just know that this is a very, very long array of 10,000 numbers. Okay, now there are a few ways in which I can calculate the norm of such a big vector, right? Calculating norms is a pretty standard thing that we always do in linear algebra. Okay, now one way is for me to do it the I would say the stupid way, which is to basically use a for loop to go through each of the numbers. I'm going to square each of the numbers. I'm going to sum the squares of all the numbers, and then I'm going to take the square root. Okay, so that's the norm, right? That's the definition of my norm. Now, if I do it in NumPy, I can, instead of doing this for loop, I can rely on the fact that NumPy does element-wise multiplication, right? So R star star 2 just means that I take each element and I'm going to square it. And in NumPy, this will be done within the NumPy code itself. I then use the NumPy.sum function, and now I use the NumPy.square-root function to take the square root of the entire sum. Okay, and then finally, in the linear algebra routine, you also have something called norm, which actually computes the exact same number. Okay, so in the Jupyter notebook, there is this special what is called a magic function in the nomenclature of Jupyter, that if you put a percentage and some special names like time, what it will do is that it will time the execution of this particular short piece of code, right? And this is very useful, especially if you are writing a very expensive to compute routine and you want to figure out where exactly in my routine is the code not being efficient and I need to actually work to optimize it further, right? So let's see how long does all these three versions of the same code run. Oops, I didn't run the previous line, so let me run the previous line first. All right, so you will see that basically the first piece of code, which I do the for loop, it took about 30 milliseconds to run, okay? The second piece of code, where I rely on the element-wise operations of NumPy and all NumPy functions, it only took 139 microseconds, okay? So this is a huge difference, okay? So a millisecond and a microsecond is essentially a few hundred to 1,000 orders of magnitude difference in speed, okay? Now, this is still a relatively small array. 10,000 elements is not big, okay? But when we are building machine learning models, very often we are encountering 10,000 by 10,000 matrices or much bigger numbers, okay? And this kind of speed difference actually becomes quite significant, all right? And you see that basically all three of them basically gives you the same answer, and but the difference in speed is very significant. All right. Now I also showed you basically SciPy also has a linear algebra package. You can also use it to do linear, do inverses and that sort of thing. There's the constants package where you can get things like your elementary charge and your Planck constant. And then I also already talked about the stats package, which actually goes through, gives you things like constructing a Gaussian distribution and calculating things like the cumulative distribution function. Okay? All right. So that's all that I want to cover for NumPy and SciPy. They are fundamental packages that a lot of the libraries that we are using would depend on. However, I will say that at least for this course, you are not going to be interacting with most of them that much, okay? The reason is because most of the time you will be using higher level libraries like pandas to actually read in data and manipulate data, and you are then going to just use scikit-learn to fit models and that sort of thing. You may need to use NumPy or SciPy from time to time to basically create arrays or to do some of the curve fitting, but by and large, I would say most of the time you will be working with pandas and scikit-learn. Okay. All right. So it is actually absolutely important for you to actually know the pandas library. So this is something that you should be working with on the daily basis, even if you are not taking this course. Okay. So what is pandas, right? Pandas basically stands for Python for data analysis. Okay. It is basically a data analysis library. It implements data structures that are essentially designed for working with relational or labeled data. Now, the best way that I can describe this to you is you think of your Microsoft Excel spreadsheet, okay? And Pandas is basically a Python implementation of an Excel spreadsheet, okay? The data that you put in an Excel table, that is basically a Pandas object, all right? There are two main data types, okay? One is called a series. A series is basically just a vector. It's a 1D array of numbers. A data frame, which is the one that you would use the most often, is a 2D labeled tabular structure. In essence, like I said, an Excel table, okay? So there are also other data analysis libraries. For example, in R, they also have an object called data frame, and essentially Pandas is similar to that implementation in the R programming language, okay? Now, as an exercise for you to, when you get home, for those of you who have never worked with Pandas before, I would recommend you go through this 10-minute guide to Pandas, okay? So if you click on this, oops, I guess the link have changed. Yeah, Pandas frequently updates their website. So if you go to Pandas, I would say it's probably this getting started. So these are the getting started tutorials, and I would recommend that you go through all of them. First of all, at the minimum, you should go through the first two, which is what kind of data does Pandas handle, and how do you read and write tabulate data in Pandas. Subsequently, you will be using everything here, right? You will be creating plots using Pandas. You will create new columns. You have to calculate summary statistics, and so on and so forth, okay? So this getting started tutorial is very useful. So just to show you what you do. So this shows you basically what a data frame is. Like I said, it's helpful to think of it like essentially a Python version of an Excel table. So you can see this is my Excel table. There's a row and there's a column. There are headers, and there's an index over here. Okay, so this also shows you basically how do you create a Pandas data frame from actual data from scratch. So for instance, if you want to initialize a Pandas data frame, so by convention, Pandas, let me first of all state, Pandas is imported as with the short abbreviation PD, okay? So PD stands for Pandas. And after that, to create a data frame, you basically call pd.dataframe. Remember that this capitalization D and F is in capital letters, and Python is always case sensitive, okay? So so I'm going to say, well, I have three names, 1, 2, and 3, Braun, Allen, and Bonnell. And I have their ages, 22, 30, 35, and 58. In terms of sex, they are male, male, and female. And I supply this dictionary to the Pandas data frame. And then if I just call print the data frame itself, you basically see this tabular structure, which looks a lot like your Excel table, right? We have our names in the first column, our age in the second column, and the sex in the third column. And then there are index numbers 0, 1, and 2 for each of that data points, okay? So that is how you actually create a Pandas data frame, all right? So I am actually going to, wait, let me go back to the slides first, okay? So definitely very helpful for you to go through that 10-minute guide to Pandas. I'm going to go through some examples of Pandas because this is such a critical library for you to learn, okay? So for the demo, what I will do is that I'm going to utilize data that have been published by the Materials Simulation Toolkit Machine Learning on Figshare. So for those of you who do not know, Figshare is basically this website where a lot of people, when they publish a new journal article on a piece of research, sometimes they need to publish the data together with it, but instead of putting it together with the, sometimes it's a bit too difficult for the journal itself to hold the data. What you would do is that you put it up on Figshare, which allows, and then you provide a link to the journal in the journal article itself, and then anyone who wants to reproduce your results can basically get the data from Figshare. Okay, so I'm going to basically download the data from Figshare, okay, and then I'm going to create a pandas data frame using some of the methods that are implemented in it. Now, let me first do something, right? You look at this link, figshare.com files 13007075. Okay, so let us see what that data looks like, right? Oops. So when clicking with that, it automatically just downloads the file. Okay, so this is my Excel spreadsheet. So let me click on it to show you what that data looks like. Okay, so this is a data set that was published together with a journal article. For now, there's no need for you to worry about what exactly that data is. It's basically a data of migration energies of different dopants. Okay, so you see that essentially this is a very, very huge Excel spreadsheet, okay, with different columns of numbers. You can see that there are pairs of elements that are related to each of these numbers, okay, and basically what we are going to do is that we are going to load that data into a pandas data frame, and then we are going to do some manipulation on it. Okay, so so the URL is given here. We are going to use a library called requests. Basically what request does is that it goes to the URL and download the file, and what we are going to do is that we are going to get the file as a text file. Okay, get the text of the file, so that's the raw data, and that raw data is actually in a comma separated value format. Okay, comma separated value, CSV. Okay, now so pandas already comes with a lot of functions for you to read different types of formats from into a pandas data frame. So it is very, very rare that you will actually create a pandas data frame by typing the data directly into the code. Okay, most of the time your data is actually in another format. It's either in a website somewhere, on a database somewhere. It is given to you in a CSV file or a Excel spreadsheet. Right? So pandas has functions to basically read all the different kinds of data file formats. So in this case, I know it is a CSV file. I'm going to put this raw data into a string IO object, and I'm going to ask pandas to basically read the CSV file and create a data frame. Okay. Now, after that, I can then manipulate the columns and rows in the data frame using different pandas functions. Okay. So let me show you the pandas example. Okay, so let me close this help. Right, so this is exactly the code that I showed you just now. Here basically this is the same URL. I'm reading in the CSV file, and I'm going to display the data. Okay, let me run this code, and basically this is what you see, right? So this is just a special Jupyter Notebook function called display, which displays the data in a nicer format. You can actually do without it as well. Okay, so if you do it without it, basically what will happen is that it is a bit harder to read, but still not fatal. Okay, so yeah, so this is basically it. Essentially, you see that there are different column names. For example, material compositions 1, material compositions 2, these are the first two columns. There is the E norm, which is the normalized energy, E raw, which is the raw energy, and so on and so forth. Okay. Now, at the bottom, you will see some statistics, right? You see that there's a summary which says that there is 408 rows. Okay, so this is basically Excel spreadsheet with 408 rows and 29 columns, right? And the 29 columns are basically what you see here. Some of these are in the nomenclature of machine learning are your targets. In other words, things, properties that you want to predict. Others are basically properties that are basically statistics or information about the composition that you are going to use, and you are actually going to predict some of these properties from these other features. Okay, so we are going to come back to this at some later date. Okay, but this particular piece of code is definitely something useful that you want to keep in mind. So when you are going through your lab, you are likely going to be copying this piece of code to read in data from some other source, and you are going to be using it for to then read it into a data frame, which you then use for some analysis. Okay, all right. Now, I also want to say that the read function, there are many other read functions. So remember, in terms for Jupyter notebooks, other than just the question mark, they also have tab completion, right? So let's say why is the tab completion not working here? Okay, so now the tab completion is working. So if you notice, if you just type pd.read underscore, you see that they actually have a lot of different read functions, which allows you to basically construct a pandas data frame from a variety of different formats. The one that we just used is basically CSV, basically comma separated value format. There is a function that you can use to read actual Excel spreadsheets. That one requires you to install other libraries to that is meant for interpreting Excel files. I do not know what a feather file is. Neither do I know what an FWF file is. Okay, all these files I don't know. HDF is a high density data format. Unless you are working with extremely big data, you are not likely to see it. HTML is self-explanatory. JSON is JavaScript object notation, something I use very often. And the rest, again, other than Pickle, I don't actually know what they are. Okay, so a lot of different support for different file formats. Okay, so just be aware of this, and in case you encounter a file that you need to read in your in some other piece of research, you will need to figure out which functions to use. Okay, by and large, we are at least for this course, we are going to be primarily working with CSV files. So the read CSV will be all that you need to do. Okay. Now, we have already shown you this actual data frame. Let's say you only want one of the rows. Let's say I just want the enorm, which is this particular row over here, this column over here. To basically get the enorm, what I would do is that I basically just use this square bracket. In essence, I'm accessing it like a dictionary, okay? And this basically gives me that entire column as a series, okay? So for a series of pandas series of length 408, okay? Now, the reason why Panda is so popular for data analysis is that it implements a lot of functions that you would actually be interested to use for analysis, right? So, for instance, let's say you look at these values, right? You see, well, some of them are greater than 0, some of them are less than 0. Let's say you are interested in only the values that are greater than 0. So all you need to do is I'm going to put data enorm greater than 0. This basically gives it creates a Boolean array column, okay, of true and false numbers. So if it is less than 0, it will be a false value, and if it is greater than 0, it will be a true value. And then I am sub-selecting the values that are only greater than 0 from the data frame. Okay. So let me show you what this does. Okay. So what you'll notice now is that I'm asking it to basically select the subset of data that for which the E norm is greater than 0, right? And I'm putting it in a different variable name. I just call it df. And then I'm asking it to describe df, right? Df is a pandas function that basically presents to you summary statistics of the data frame itself, right? And the first one says count. Okay, count means how many data points there are in each column. And you notice that all these are of course the same. So 177 numbers. So instead of 408 numbers, now I only have 177 data points, right? And the reason for that is because only 177 data points have an E norm of greater than 0. Okay. You also notice that they actually provide you with the mean of each column, the standard deviation of each column, the minimum, the 25th, 50th, and 75th percentile, as well as the max value. Okay, so this describe function is actually very useful for you to just get a quick overview of your data. Okay, yep.
So if, say, the data that you're taking it from the website, like all the columns had to do with like an equation that was in the beginning, and if you changed one thing, it like changed all the other columns. Would you be able to do that with Python somehow? If like you're like, okay, the first column it's 1 through 10. I want to add 1. Can you have it where it changes every other outcome?
Yes.
It needs it.
Yep. And it's actually a lot easier to do in Python. So I know. So you are talking about Excel formulas, right? Essentially.
Yeah.
So yeah, it's actually it's actually a lot easier to do in Python. So I'm going to show you some operations that you can perform on the data frames themselves that will help you. And I also want to highlight is actually very recent news that Microsoft Excel just announced that they introduced Python scripting within Excel itself. So nowadays, in fact, it was just like 2-3 weeks ago. So nowadays, you can actually use Python code within Excel. As a former user of Excel, I really dislike Excel way of writing functions. It's ridiculous, right? Python is a lot more powerful. There's a lot of things you can do in Python that you can't do in Excel. Okay. All right. Just to show you that, I'm going to come back to that question later. Okay. So pandas also comes with some convenience functions, right? So for example, let's say you just want to visualize the relationship between two different columns. Okay. Well, let's say the E norm and E raw, you want to see, well, is there a correlation between them, right? So like I said, don't worry about what the meanings of these columns are for now. I'm just showing you what you can do with pandas, right? You can just take the data frame, you say plot. On the x-axis, I want the E norm, and on the y-axis, I want the E raw, and I want to plot a scatter plot. And basically, what you get is something like this, okay? And this basically plots a scatter plot of the E norm on the x-axis and the E raw on the y-axis, right? Now, to answer your question, you said, let's say I want to add something to each column, right? So let's say I want to take the multiplication of the E norm column and the E raw column, right? Now, let me go back. Let me show you the data frame again. Okay, so this is the data frame, right? Right. So this is my entire data frame. At least the subset where the E norm is greater than 0. Let's say I want to do what we typically do in Excel. I want to take this element, multiply by this element, and I want to create a new column. Now in Excel, you go in, you create a new column. formula A1 times B1, and then you copy and paste, right? Now, here is actually a lot easier, okay? So instead of doing that, I'm going to say okay, I hope I got the spelling name correct. So I'm creating a new column called result, and the result column is going to be equals to my enorm column multiplied by my raw column. And one thing to remember is that you can almost always treat like each of the columns of the data frame as essentially a NumPy array. The multiplication and all operations will be basically element-wise. Okay, so let me do this multiplication. Okay, now it's not showing anything because wait, give me a second. I didn't provide the results. Okay, and you will see that now instead of originally I had 29 columns, now I have 30 columns, right? Okay, and if I scroll across, unfortunately it's at the end, this is my result column, and this is basically the multiplication of my enorm and eraw for each number. Okay, so that's basically how you do exactly the same thing in pandas. Okay, any questions, other questions regarding pandas for now? This is a very, very quick overview, and I know it's probably like a bit abstract, but once you actually start working on your first lab, I assure you, you will become intimately familiar with pandas. Okay? Okay, let's continue, right? Now, these next two packages, I'm going to talk a little bit about them. I'm not actually going to talk too much about them. The main reason is because all things of substance regarding these two packages, I have to get to the machine learning part of the course before you actually can appreciate them, right? So the next two packages I'm going to talk about is scikit-learn and TensorFlow. They are essentially packages for machine learning, right? And in many ways, scikit-learn and TensorFlow do overlap in some functionality, all right? For the purposes of this course, we are only going to focus primarily on scikit-learn, right? And the reason being that scikit-learn in terms of for beginners is a lot easier to get into, right? TensorFlow is notoriously difficult to get into. It is very powerful, but unless you are doing very heavy machine learning model development, I wouldn't recommend that you start from that, right? And in any case, once you actually learn scikit-learn and you understand the principles of machine learning, eventually if you are interested in going into more in-depth development, you can actually go into TensorFlow. Now, I'm not going to talk about the specific code examples of scikit-learn and TensorFlow. Essentially, they implement all the common machine learning models that we would be covering in this course, right? So things like linear regression, your standard simple linear regression, your kernel regression, neural networks, you name it, the likelihood is that they are implemented in scikit-learn and TensorFlow, right? For now, I'm only going to talk about a very high-level overview of the application programming interface of our scikit-learn, right? And the reason why we go through this is that once you understand the high-level API, subsequently when we talk about linear regression and kernel regression and all that things, it becomes very simple, okay? All right. So the scikit-learn model API is standardized, right? All the machine learning models that are implemented in scikit-learn, they inherit from this class that is called the base estimator, right? They do have some mixing classes depending on whether it is a classification model or is it a regression model. But by and large, they all implement exactly the same method names. So typically, the way that you will use a scikit-learn model is that you will initialize it with a model name, and then you give it some parameters. So for example, if you are doing a simple linear regression, you may, for example, define what are the regularization parameters. If you are doing a neural network, you may define the number of hidden layers and how many neurons there are in the hidden layer, and so on and so forth, right? All the models also implement get parameters and set parameters. The names are self-explanatory. So let's say sometimes in the middle of working with a model, you want to find out, what parameters did I set? Or maybe you loaded a pre-trained model from somewhere else. You want to understand what parameters did they use to actually define the model. You use the get parameters method. Set parameters means, well, I'm maybe halfway through, I want to try a different set of parameters for my model. I'm going to set the parameters. Then to fit the model, there's always a function called fit, okay? And you give it x and y, right? X is always necessary. X is basically your input feature set. Y is your target. Now, if it is a supervised machine learning model, you have to define both x and y. If it is an unsupervised machine learning model, which we will talk about later, you provide just x, okay? Then there are also the functions called score and predict. Score just means you basically score how good the model is after it has been fitted, and predict, basically you give it new data or the same data, and you ask it to make a prediction of your target, okay? So all these function names are going to be exactly the same no matter what model you are using, okay? It doesn't matter whether we are using a linear regression model, neural network model, the function names are always exactly the same. The only thing that will be different is this very first line over here, the name of the model and the parameters that you give it, okay? So that's the major difference between the different models, right? So once you actually understand this high-level API, you will find that scikit-learn is very easy to work with, right? If I try a new neural network model, or if I try a new random forest model, I don't really have to change a lot of my code. I may basically just replace that first line of initializing the model, and I basically can calculate a different set of results, okay? All right. All right, the final two libraries that in the scientific Python package that we are going to talk about is matplotlib and seaborn, all right? So these are basically plotting libraries, right? Matplotlib is the de facto library for generating all kinds of plots, right? So in fact, almost all the other plotting libraries, including seaborn itself, is built on top of matplotlib. You can get very, very good results with matplotlib, all right? So you can actually make publication quality results if you go ahead and mess around with all the tweaking of all the different parameters and that sort of thing. The problem is, of course, that sometimes it takes a lot of code to get it to do what you want, right? This is where something like seaborn comes in, right? Seaborn is basically a plotting library that is primarily designed for statistical data visualization, right? And the design of seaborn is such that it works extremely well with your pandas data frame, right? So just to show you a few code examples, let's say you want to plot the two variables with as markers and solid lines. So let's say you have a list of numbers in x and a list of numbers in y. You import matplotlib pyplot as plt, and then you just plt.plot x and y. Basically, that gives you the plot. If instead of using x as markers, you want to use a circle as markers, you just give it O. Dash line means two dash instead of one dash. That gives you a dash line instead of a solid line. And that's basically how you do it in matplotlib. Now, seaborn is a bit different. Seaborn, they are basically pre-designed plots in a way, right? And those plots are already very nice looking in themselves, right? So for example, in Seaborn, you can plot distribution plots. You can also do the same thing like this, which is a scatter plot, but here you actually work with a data frame. Let's say the data frame is called materials, and you want to plot, for example, the melting point versus the bulk modulus and so on and so forth, okay? Now, one useful thing that you might want to look at is called the Seaborn gallery, okay? So if you click on the Seaborn gallery, you see that these are all the different kinds of plots you can actually plot using the Seaborn library, right? So there's your standard scatter plots, there's your standard bar plots, there is your heat maps like this, okay? Very often you see this in the in publications, and yeah, there are basically all the different kinds of plots that you are interested in, okay? And if you want to know how to do something, this is extremely useful. You just click on one of them. Let's say you want to get this heat map yourself, and this basically shows you how you actually go about plotting this with Seaborn, and they show you basically it's just a function called heat map. I'm giving it the data set. This is a data set that comes with Seaborn. It's called flights, and how do you go about drawing the heat map, okay? All right. Let me show you a little bit. We are going to just use Seaborn here. Let's say, remember I have my E norm data, right? Let's say I want to see a distribution. What's the distribution of my E norm, right? Which is the normalized energy, right? So all I need to do is that I will import Seaborn as SNS. This again is just a convention. I want to do a distribution plot. That's done by using the function called displot. I'm going to give it the data frame, and there is a parameter that I want to set, which is do I want to normalize the histogram or not. In this case, I want to say no, because I want to see what the values are. And once I plot it, and this is basically what you get, right? This is a very nice looking distribution plot. You can control the number of bins here if you want to, okay? If I'm not wrong, see? So this uses 50 bins for my histogram instead of the default, which I believe is 10 bins, okay? And they also try to fit kernel density, which you are going to learn about subsequently, and plot it over here, okay? You can also use Seaborn to do scatter plots. This is basically the exact same plot that we did using the data frame scatter plot function, okay? So the way that you use Seaborn with pandas data frames is typically that you give the data frame as the keyword argument data, and you specify, well, for my x, I want it to be the E norm column, and for my y, I want it to be the E raw column. And this is basically the scatter plot of E norm and E raw, okay? All right. Any questions regarding Seaborn or Matplotlib or any plotting of the plotting libraries? Yeah.
I'm just a little confused at why you typed out the percentage Matplotlib.
Yeah. So it used to be that in order for the plots to appear inline in the Jupyter notebooks, you actually need to have this magic function. But actually, this is unnecessary nowadays. Even without this, it works perfectly fine. So yeah, that's just a holdover from older versions of Jupyter notebooks where you actually have to specify that you want your plots to actually appear in the notebook itself.
How do you get an outcome to not appear?
An outcome to not appear?
Yeah.
Oh, that's easy. Just put a semicolon.
That's it?
Yeah, so for example, let's say if I just type df, that's my data frame, it will appear, right? But if I put a semicolon, it doesn't appear. The other way is, of course, you assign it to a variable, okay? You can always do a dummy operation like this, which basically assigns the data frame to the last variable, which is in Python, it has the special symbol underscore, and this will also cause it not to appear. So either one would do, but yeah, I usually just use a semicolon. Any other questions? All right, if not, let me continue. And we are getting to the end of at least this lecture. All right, so now that we have covered the entire scientific Python library, there is one last thing you need, which is you need a library for materials analysis. Okay, this is a data science in material science course. It's not a data science course, right? So you definitely need, well, you don't need it. Of course, you can do it without any libraries to help you do materials analysis, but it helps a lot if you actually have a library that helps you do materials analysis, okay? So the materials analysis library that we are going to be using is called Python Materials Genomics, or PyMatGen for short. It is basically the core materials analysis library that powers the materials project today. Materials project is basically this big database of open materials data that a couple of us developed when starting from 2012. Okay, and I'm actually the main developer of PyMatGen. Okay, so this is actually a library that I wrote. Today, it basically has around a few 100,000 users worldwide. Okay, it is one of the de facto libraries that a lot of people use nowadays for doing materials analysis, right? So what does PyMatGen do? It basically defines core extensible Python objects for various types of things that you will work with in materials, okay? So things like what is an element, what is a composition, what is a crystal structure, what is a molecule, all these things are defined within PyMatGen. It also provides a robust and well-documented set of analysis tools, both structure analysis as well as thermodynamic analysis. So for example, let's say you want to take a structure, you want to create defects in it, or you want to cleave it to create a surface. All these things can be done in PyMatGen. If you want to construct a phase diagram, analyze the energy of a reaction, again, all these things can be done in PyMatGen. It is also an open source code, so I'm by no means the main contributor, only contributor to PyMatGen. There have been a lot of contributions from different researchers over the years. Okay, and finally, one of the most important parts about PyMatGen that is especially helpful for you guys is that it has high-level methods to access the Materials Project API. Okay, the Materials Project API is basically an application programming interface or REST interface for you to actually download data from the Materials Project without having to go through the website and doing thousands and thousands of mouse clicks. Okay, all right. So this is an overview of the capabilities of PyMatGen. So essentially, this is a typical workflow, right? You usually start from some input or output. So things like your electronic structure calculations, or maybe you download a crystal structure file from somewhere. PyMatGen have tools for you to read in those files. You then what you get after you read them in is basically similar to pandas. You basically get a Python object. In pandas, the object that you get is usually a data frame. In PyMatGen, it can be something like a structure, a molecule. It can be something called a computed entry, which in essence is just a container for a structure together with various properties like the energy and that sort of thing. If you do electronic structure, there's things like the representations for the density of states or the band structure of the material. And then you can also, then there's a extensive suite of analysis tools for you to do things like phase diagrams, reactions, and so on and so forth. Okay. You are not actually going to be working with most of these functions in PyMatGen, except for manipulating structures and compositions. Okay. The main reason is because all these are essentially related to the material science of things. Just keep in mind that this functionality exists so that in case you are interested, if you are actually going to do such analysis in your research or in some of your projects, you might be interested in using them. Okay. Now, the most common thing that you will be doing with PyMatGen, however, is to access the Materials Project API, right? So in PyMatGen, there is this package called PyMatGen.ext, stands for external.mat project. There is this class called the MP Raster class. So basically, what the MP Raster class provides you is convenience functions for you to query for crystal structures and other object types from the Materials Project. Okay. So the method has to be used in conjunction with the Materials Project API documentation, and this is basically how you go about using it. You initialize the MP raster with an API key. Every single one of you will need to get one from the Materials Project. Okay, and once you get that, then you put it over here, and then you can do things like, well, let's say I want to get all the formulas and formation energies per atom of structures in the Materials Project with the formula Fe2O3. This is basically how I go about getting it. Okay, and once you do that, you can then also take the data, and then you can create a data frame from that data. All right. Now, let me first show you how you would do it on the website, and I will show you the equivalent of how you do it via the API, and things will become a lot clearer, right? So this is the Materials Project website, okay? And as of today, there are 154,000 crystal structures within the Materials Project. There are 385,000 registered users. I'm not going to talk about citations, but if you are interested in things like the energies, the density of states, this chart basically shows you the statistics of the amount of data that is in the Materials Project. Now, just to give you a sense of what kind of data is within the Materials Project, let's say okay, so you need to log in using your Google account. It can be any Google account, and they may actually prompt you to create an account by giving some very basic info like which institution you are at. Okay, interesting. Okay, I will be a student, undergrad student for the purposes of this. Okay, so I actually have an account under my actual Google account, but never mind. So once you are here, you are confronted with this thing called the Materials Explorer. Let's do exactly that query that I want. Let's say you are interested in iron oxide, right? And you want to know what are the forms of iron oxide there are. You just type Fe2O3. This is basically the formula for iron 3 oxide. And you notice that while there are about 26 materials with the formula Fe2O3 in the Materials Project, they have various different kinds of crystal systems, number of sites, energy above Halls, and band gaps, and so on and so forth. Now, let's say we just click on one of them, and basically what this brings up is basically this details page, which gives you some of the computed properties of this iron oxide, the space group of the iron oxide. Well, the band gap of this iron oxide is 0 for some reason. This obviously is not correct. The formation energy, and so on and so forth. And you can actually look at, for example, the crystal structure over here. Okay, And once you actually go down, you can see that there's been a lot of properties that have been computed. Things like, well, the phase diagram, the electronic structure. This is the band structure of iron oxide. And if you are interested in the diffraction patterns, you can get them. There are some magnetic properties, elastic constants, dielectric constants, and so on and so forth. Okay, so bottom line, there's a lot of data within the materials project. So if you are working on a project and you have a material in mind and you are wondering, well, maybe I need the bulk modulus of this material. Is there a calculation that has been done on it, and is there a value for the bulk modulus that I can use for my work? The materials project is always a good source to try. Okay. Now, obviously, you can get the data this way, right? Well, the very silly way to do high throughput data analysis is to go to use the website, and then you click on each one in turn, and then you copy and paste the data one by one. It will take you forever. Let's say if you are doing 1 million materials or 100,000 materials. Okay. The faster way is to use the materials project API. Okay. And the materials project API basically allows you to download all the data in one shot, and you can then get the data immediately for you to do analysis. Okay, so let me do this final example over here. So since I am running this on Google Colab, what I need to do is to basically, I need to install PyMatGen itself. I actually don't need this anymore because that used to be in the past. Okay, so PyMatGen does not come directly on Google Colab. Okay, for Google Colab, you actually need to use this !pip install PyMatGen to basically get PyMatGen to install. Okay, and it will take a little bit of time to run this. Okay, you can ignore all these messages. Okay. Okay, that was faster than I thought it would be. Okay. I'm also going to do, I will correct this data. Okay, so what I'm going to do is that I'm going to import MP raster, and remember what I need is the materials project API key. You can get your own. All right. So I'm going to get my materials project API key over here. You just need to go to the GitHub website. I already show you an example of how you go about getting your materials project API key. But once I have the API key, I just copy and paste it over here. Instead of using ChemSys, what I'm going to do is that I'm going to do the exact same example as what I have in the lecture, which is using formula. And I'm going to get these 4 properties, and let's see what this does. Hopefully it works without problems. Okay. Okay. Let me first correct this. I will actually fix the code once I get back to the office. Okay. Okay, now let me see if this code now works. I will update this notebook when I get back so that you guys will have the latest version that works, okay? Oh, okay. Don't worry, this is a small thing. All right, so once I actually do a query, you will see that I'm actually obtain all the data. This basically gets documents from the materials project. I'm asking for a summary of the materials ID, formula, the formation energy per atom, and band gap of all the Fe2O3 materials. Here I'm just showing you one of the data points, and you can see that indeed I basically get this Fe2O3 material. It has an ID associated with it, which is called the materials project ID, the formation energy, and the band gap of the material, right? And you can also dump all the data into a data frame. So this shows you and here you can see that basically 26 rows. This is exactly the number that we saw on the materials project website. So we have managed to obtain all 26 data points from the materials project. And you can then look at the data over here in the pandas data frame, okay? Now, I'm going to drop NA and, oops, okay. All right, I'm going to go to fix the notebook first, and then we'll continue on in the next lecture, okay? But basically, the materials MP raster just basically gets you all the data that you get that you need from the materials project without having to go through the website, okay? Thank you. So the way that you actually access the materials project API is using what is called the MP raster, right? So this is a class that is written in PyMatGen. And the way that you use this is fairly simple. You basically initialize the MP raster given using an API key. To get the API key, what you need to do is to go to the materials project website, sign up for an account, and under the dashboard you will see there that under your account information you should see API key that is unique to you and you only, okay? Now, you shouldn't divulge the API key. Of course, when you are doing your labs, by all means leave the API key inside the lab. We are not going to use your API key because we have our own, but if you are sharing a public code, you shouldn't divulge your own API key, okay? Now, once you have the API key and you initialize the MP raster, basically you can then use various functions to basically get information from the materials project based on certain criteria of materials, okay? So for instance, what this particular line of code that you see here shows is basically I'm using the MP raster to search for materials that have the formula Fe2O3. Okay, so this is very standard iron 3 oxide. And the things that I want to download from the materials project are, one, the formula itself, two, the formation energy per atom of the each of the materials, and finally the band gap of the material. Okay. Now, once you get the data, this shouldn't take that long, so this should be just a few seconds, and then you can print the data or you can convert it to a pandas data frame. Yes.
You said we shouldn't share the API key, but does it apply to when we submit the homework as well, or does it not matter?
It doesn't matter if you. I mean, we have our own API key, and of course the instructors are not going to divulge your API key, so you can just submit it. But even if you don't put your API key in the homework, my setup is such that it will run the code without the need for an API key. So, and that will ensure, your code will run regardless. Okay?
But it doesn't matter if we leave it in.
It doesn't matter whether you leave it in or not. Okay? All right. Now, to show you how this is run, so I'm going to go to this code right here. So if you are doing all this in Google Colab, what you need to do is to run pip install PyMagen, because PyMagen by default is not installed in Google Colab itself, right? So this is pip is basically a standard Python package installer, and the version of PyMagen you need is 2023.10.4. This basically says is a version of PyMagen that is released after October 4th, okay? So what happened was that the Materials Project API was undergoing a few changes, okay, from the previous year that we actually ran this course. So I actually had to make some changes to PyMagen itself in order for us to use the API. So so you need a relatively new version of PyMagen, okay? So 2023.10.4 basically was the version of PyMagen that I actually updated just a few days ago, okay? Now, the next few lines of code doesn't really apply to you. Those are for the purposes of demonstrating code on over here. What I want to do is that I don't really want to type in my API key over here, because otherwise I'm essentially divulging the API key, my API key. So I'm mounting from Google Drive a JSON file that I myself wrote that has the API key. So this basically just do that. So I'm going to run an installation right now, and we'll just wait for just a few seconds for this to be done. And yes, you have a question?
If you already installed PyMagen, do you have to uninstall and reinstall that update?
If you use that line of code, essentially it will install a new version, so no problem. So you do have to reinstall, but that line of code will just reinstall a new version for you. Okay? All right, it seems that the code has finished running. Okay, and now in order for me to use MP raster, I need my Materials Project API key. So I already loaded that data. I'm going to just use that dictionary that I just loaded from this JSON file, and my API key is in this key, and I'm going to run this, and you see that I'm getting materials with the formula FE203. I'm looking for what is called the materials ID, which is a unique ID that Materials Project assigned to every single material. As I mentioned, I want the formula, I want the formation energy per atom, and I want the band gap. And you see that that's basically what is returned, right? So I'm only printing out one of the materials, okay? So what is returned by the Materials Project MP raster is basically a list of dictionaries. So I'm only taking out one of them to show you what is the content of that dictionary. And you can see that basically that's exactly what I requested for, okay? Now, very often, you don't just want to work with a list of dictionaries, right? It's not really a very friendly output to use. So if, let's say, you want to convert that data, all the data into a data frame, okay, a pandas data frame, you just need to supply the data as an initializer to the data frame itself. And, oh, okay, the reason here is because I didn't import pandas yet. And you see this is basically all the information that I already downloaded from the Materials Project, okay? So the formulas are all the same, of course, because I specifically requested for materials with the formula FE203. You will see that the materials have different formation energy per atoms and different band gaps, and of course different Materials Project IDs, okay? So in your lab number 1, basically what you will be doing is that you'll be using essentially a variant of this code. You will have to figure out how to modify the code that I just showed you to basically download information from the Materials Project, and then do some further data scrubbing and analysis on that data. Okay. All right. Okay. Let's say, as I showed you before, let's say you want to see whether there's a relationship between the band gap and the formation energy of the data. And usually what you want to do is also you want to scrub the data. So in this case, there's no invalid data. But let's say I want to scrub the data to remove everything that has not a number in it. I just call this pandas method called drop NA. Drop NA just simply means I'm going to drop all data that has not a number in it. And then I'm going to basically plot the scatter plot to show, again, here I didn't import C1. And, oops, what is this? This is a weird error. I've never encountered this. Okay, but basically if you run this, well, I'm not going to worry about this for now, but basically if you run this on Google Colab, what you should be seeing is basically a plot of the band gap versus a scatter plot of the band gap versus formation energy of the data that you just downloaded. Okay? All right. Any questions regarding the Materials Project API? You will be playing around with it in your first lab. So, yeah.
So you said it's only for Google Colab where we have to do the pip install. So if you're doing it on Jupyter, the Jupyter notebooks,
you should already have PyMagen installed if you are running it on your laptop. So then, of course, you don't have to re-pip install it.
So you just have to do like the import stuff.
Yep.
Okay.
Yep. It's only in Google Colab that because Google Colab doesn't come with PyMagen pre-installed, that you have to do pip install. Yep.
Do the magic functions work with PyMagen, or is there documentation for?
Yes. So PyMagen is extremely well documented. So if you are interested to, if you want to know what each function does and what the method signatures, you can also use things like the question mark magic functions and that sort of thing. Okay. So the magic function basically just looks at the documentation and it spits out the documentation. So as long as there's documentation written, then it will come out. So yeah, and PyMagen is very, very well documented. All right. Any other questions regarding this? All right. So this is just a very simple sample code. So in your lab first lab, you will basically, you can copy and paste this and then do whatever necessary modifications to the code to do what lab 1 asks you to do. Okay? All right.